All right, so um, good evening, everyone. Welcome back to the 12th week and the last live session for the course Artificial Intelligence Knowledge Representation and Reasoning. So, yeah, I guess it's about 6 now, so we'll begin in a minute or two. Um, just an informal announcement or a heads up. So, Professor Deepak Khemani might join us in maybe half an hour or so. So, uh, since some of you have been requesting to want to meet him to share your thoughts on your experience with the courses, this one as well as the previous one, if you had attended that. Um, so yeah, I talked with him and he has uh, said that he might join in around 6:30. So you can share your thoughts with him, your experience of the course, and also you can ask some general doubts. So he won't be with us for very long. uh, but you can ask some general doubts. And yeah, that was the announcement before starting. Um, yeah, good evening once again, Vipul and Darsh, and also Arkuti. So I was just saying that since some of you had requested to meet with Professor Deepak Khemani, he has kindly agreed to join us for a very brief time. He might join the meeting around 6:30 or so. Yeah, so I guess the others will join in by that time. Um, in the meantime, let's get started with today's session. So today we are going to, since we've already covered all the 12 weeks of the course, yeah, I tried finding a previous year question paper, but unfortunately I wasn't able to. So I framed some questions myself, kind of covering all the 12 weeks of the course. Not that they are representative of the kind of questions you might get in the exam, but they are very similar to the kind of questions we have discussed till now in all the live sessions. And I have tried to keep in mind the topics that I personally thought uh, might be beneficial for you all to kind of look into before your final exam if you're appearing for that. So yeah, that's about it. And let's get started with the questions, unless any of you would like to add something before we start. Uh, Hi Bhaskaran sir. So, am I audible? Hello. Okay. Thanks for confirming, Vipul and Orkudip. So, I see we are joined by Bhaskaran sir as well. So, thanks for joining, Bhaskaran sir. And as I was saying that some of the students, some of the regular attendees of the live sessions had been requesting to meet with you and Professor Deepak Khemani. So, it's very kind of you to join us. So, any of you who would like to uh, share your experience with the course or your this one or the previous one, you can please feel free to speak up. Sure. So in the meantime, Bhaskaran sir joins with his phone for audio. Let's continue with the session, and once he is joined, you can have a brief discussion or share your thoughts about whatever you wanted to share, your experience of the course and such. So let's get started with the questions. As I said, we'll be covering some questions from all the weeks of the course, kind of a brief overview. So here's the first question in front of you. So you have been shown a domain and the figure on the side of the panel, and you have to say which of the following statements are true in the domain that has been shown here. Okay, so you can go through the options while I'll create a poll for this question. Yeah, so I've created the poll. You can share your thoughts over there. Um, Thanks for your answer in the chat, Vipul. So Vipul says that C is one of the answers. What about other options? Is there any more correct option among these? They have been given 6 options, and one or more of these could be correct or incorrect, right? So have a look at all of these options, and then we can have a discussion. So in the polls, we have one vote for options A, C, and E. What do the others think? Okay, so I guess we have another vote through the chat reply. Thanks, Srikanth, for your answer. Srikanth also said that A, C, and E are the correct options. And let's have a look at the answers. So yes, A, C, and E are in fact the correct answers because, okay, let's go through the options one by one. So option A says there is at least one red triangle, which we can see there is in the domain given here. There is option B says there is at least one red circle, which is not true, hence the option is incorrect. There is at least one green pentagon, which is also correct. Option C is correct. There is at least one green circle, which is again incorrect. There is at least one yellow circle, which is true. And the last option is again incorrect. So A, C, and D are the correct options. I hope there is no doubt about this question. It was a pretty straightforward one. Shall we move on to the next question then? Okay. Thanks for the confirmation, Orgodeep and Shrikant. Um, so, Bhaskaran sir, is your audio fine now?
Hello.
Yeah, hi, sir.
Hello. Hi. Hello, everybody. This is Bhaskaran. Okay.
Yeah, so everyone, so to the new joinees, so we have Bhaskar and Sir among us today in the meeting. So if you want to share your thoughts about your experience with the course and how you're liking it, this one or the previous one or both of them, please feel free to unmute yourself and please go ahead.
Also, is Professor Deepak Kamani joining us?
Yes, sir. He said that he will try to join around 6:30 or so.
6:30 or so. Oh, it's very good. Okay.
Yeah.
Okay. So, what is the current topic? Any hot questions?
So this week we are just going through all of the weeks, some representative questions from all of the weeks. That's what I planned today, since we had already covered the 12 weeks content in the previous live sessions. But yeah, if any of the attendees wanted to ask something specific that could be answered briefly, then I would encourage them to please go ahead.
Hello, sir.
Yeah.
Yes, sir. My name is Orgodip, and I attended the SMPS course as well last semester. It was a very good experience. I also gave the examination, and I got a elite certificate. And I'm looking forward to the examination on Saturday. Sir, my question is, can you sir just say some important topics among the 3 weeks to focus on for the examination on Saturday?
Okay.
And another question, sir, how to do those prologue questions which we needed the prologue software? Will those kind of questions will be on the examination? That is a question, sir, because we will not have prologue there. So that will be, sir, very helpful.
Okay. I'll address a product question first because it is much more specific. See, the prologue material that Professor Deepak has presented is one of the best material you will find anywhere on the internet. It's such a he has presented the core principles of logic programming and how Prolog implements it and how to use Prolog to understand those principles. So now the questions that we have set up in the assignment, also in the exam, they are really simple toy examples to illustrate the foundation of logic programming. Okay. So if you understand the principles, then you don't need a Prolog interpreter to answer those questions. They're all simple enough questions. First, you should understand that. Okay, it doesn't require enormous amount of computation to answer these
Okay,
questions.
sir. Okay, sir.
Okay,
Okay, sir. Thank you very much.
so Prolog interpreter will not be provided in the exam. Okay, will not be provided in the exam. Uh, but if you use Prolog interpreter to understand the assignment questions, use the trace facility, then you will get a very good grip on logic programming concepts. Okay, so that is the whole idea. Yes, we have prologue questions, and like the other courses, Professor Deepak's courses, the final exam will be a small version of all the assignments put together. Okay, you will have content from all 12 weeks. So if you manually work out all the problems in the 12 assignments, then you will be, you know, uh, good for the exam. You can easily, crack the exam, get top marks.
Okay, sir. Thank you.
Okay.
Sir, another thing I noticed on the examination of SMPS that there were no recall-based questions. So, will there be any recall-based questions? Or should I focus on any recall-based questions from the lectures?
SMPS is a little bit different than KRR in the sense that SMPS is more of an application-oriented course. So Professor Deepak Kamani, he keeps it, he targets the people who are going to practice this in the industry. So the course is oriented towards solving problems by hand, understanding the algorithms and the nitty-gritties of algorithm, the complexity and behavior and characteristics of algorithms, and so on and so forth.
Yes.
KRR is a little bit different. Yeah, you will have recall type questions, definitely. And you will also have proofs and things like that you have to do.
Okay, sir. Okay. Thank
Okay.
you, sir.
Yeah, sure. See, one common thing that I get every year is, see, when we have questions with multiple answer types, sometimes we take a single answer question and then set it up as multiple answer type question. Okay, that happens rarely. Say 1 in 100 question will get set up like that, and it happens only when the question is too simple to answer. A very entry level question, then just to increase the level of difficulty, we'll just set it up as a multiple answer question. Otherwise, in general, we don't do that. So when there's a multiple answer question, definitely you will find multiple answers there. Okay, only in rare cases we do that. I think this time we don't have such mix up. If it is single, it is single. If it is multiple, it is multiple. See, okay, if you don't have question, I would like to say this about the KRR course itself and how it fits into people's professional career. See, yeah, knowledge representation and reasoning is one of the foundational fundamental courses that helps in modeling systems. If you're a database programmer or a web programmer, or you're going to do AI, uh, if you want to represent some data, so it says knowledge, representation, and reasoning. So we have knowledge. We want to be able to store knowledge, modify it, use it to infer new things, and so on and so forth. So we have a knowledge component. We have a representation component. So for a given application, we have to find a suitable representation. So usually the representation depends on how you're going to access the knowledge. Okay, it is somewhat similar to database design. A database is designed based on the queries that are going to be fired. So if I have 10 types of queries, say in a share market situation, people are going to ask what is the price of a share, and I want to place a buy request, I want to place a sell request. So these are the kinds of queries that are run against a database. So the database will be structured and optimized to service those kind of queries. Similarly, in a knowledge representation system, we will the representation part. See, there is a part of representation that is common, that is independent of what queries we are going to answer. But there is a component which is specific to, we have to design the representation in such a way that the system runs faster and provides an answer quicker for the types of queries that we are going to face. So you have the representation component, and there's a reasoning component. Okay. So this course, if you have understood the foundation, the fundamental principles, you will see that these principles are applied across many domains in the software industry. Okay, so you will see a major component, major parts of knowledge, representation, and reasoning in almost all of the fields, including machine learning. So if you look at machine learning, then you dig deeper, then you will see some parallels. You will see there is some amount of knowledge that's being captured somewhere, and there's a representation and a reasoning component. Okay. So this is the general observation dealing with this course over the years. I have a good industry experience, about 15 years I've been in the industry, and I've seen applications where the KRR knowledge is directly applicable. But nobody will say that, okay, use KRR for this project, or use KRR to design such a module, or provide a solution for this use case. Nobody will say that. But people who have gone through KRR will actually map it to KRR, and then they'll solve it. So KRR is a very essential part of computer science and So design, modeling, providing solutions, and so on. You could also nowadays, ontology and semantic web are very popular ways of collecting knowledge and reasoning about those knowledge, right? Asking queries and inferring new knowledge from the existing KB and so on and so forth. So people who are interested, they can focus on description logic and OWL. So, and that's one of the uh, tools that is used in the industry currently for gathering and reasoning about knowledge. So we did a project for Ford, which has an ontology uh, that was written in one of the early languages called KL1, and we re-engineered that to OWL. And I cannot disclose too much about the application because of non-disclosure, but I can say that application drives the entire, what do I say, how do I phrase it? The assembly plant operations. I'll put it this way: if not mentioning a specific company, I'll talk in terms of general application. If there is a company, it can be manufacturing company or any other company where there is an assembly line. And if we want, as an owner, if we want to know, if we want to design an assembly line that is efficient, and if we want to know how much labor costs are incurred in running such an assembly line, if I want to optimize the labor cost, if I want to optimize the entry and exit times of the products in the assembly line, those are optimization problems. Then we need to be able to capture the activities in the assembly line in software. So we used OWL to capture that knowledge and do reasoning over it, and then answer some queries for the purpose of optimization, for the purpose of daily, maintenance of or execution management of the assembly line and so on and so forth. So that is one of the critical central applications that is used to optimize assembly line. So the content that we have covered here has practical applications in the industry. Okay, anything else, Ritus? Yeah, you can go ahead with.
Yeah, thank you so much for
Yeah,
sharing your thoughts, Bhaskar, sir.
yeah,
Uh,
sure.
would anyone else like to share share anything they wanted to? I see a few regular attendees. So Darsh, Mohan, Shrikant, or any of the new attendees as well. If you want to share anything, please feel free to go ahead. So yeah, Darsh, you were saying something. Please go ahead.
No, sir, I'm okay. I just listen to what everybody is asking. Thank you.
Okay. So I will ask you questions then. How do you find Tableau method? I mean, do you guys have a grip on Tableau method?
It's clear when we are reading, but after a while we lose it from memory.
Okay.
That's what the real problem here is. Most of the things are really good when we read, but the
Okay.
retention of that one in the memory and recollecting it to answer the questions is a big challenge. Uh, I mean, probably you can tell that one I got to need a lot of practice.
Okay. So that's a general thing with most courses, but especially with logic-driven courses. KRR is a logic-based, mathematical logic-based course. If you understand the foundation, then it becomes natural for you to. You'll say, okay, if you understand the foundation of Tableau method, then you will say, yeah, it's obviously this is the right way of doing. I mean, everybody should know this. No, it's so obvious. What is there? What is special about this? So, but to bring a student, a participant to that zone where they get a aha moment and they say, yeah, I got it. Okay. That's what we try to do by our assignments are geared towards pushing the participants into a zone where they will say, oh, yeah, now I got it. Okay. So you correlate the lecture with the assignment problems. You should be able to, get the basic idea. So one thing, now it is too close to the exam, but in general, I would say with Professor Deepak Kamani's courses is that you work out the example that he works out in the lecture on your own without looking at the lecture. So you go through the lecture, you understand what the idea is, and then use pencil and paper without looking at the lecture, and you solve that problem on your own on paper. Okay. And now you try to do that for the assignment. When you have doubts, fire a question in the forum. We are happy to assist and help. And of course, live session, Ritvas will be able to answer a lot of questions in live session. You will be able to cover a lot of ground that way. Because Professor Deepak's courses very illustrative. He takes an example and runs through it. But sometimes, even to me as a TA and to some of the PhD students and senior people, some parts of the lecture will appear to be tedious, very dense, very repetitive. I would say Professor DK is able to reduce some of that tediousness. At least he's able to cover the topic clearly. Yeah, though it appears to be tedious, but if you are able to go through it, slow down a little bit, go through it, then you will gain a lot of knowledge from the lecture. It's all illustrated very well. Hi, sir. The professor has joined.
Hello, sir. So you're on mute, I think.
Hello, hello.
Uh, Hi, sir. So,
So I see that Bhaskaran is saying something. So let him. Bhaskaran, why don't you continue?
Yeah, I am almost done. I was talking about, I was saying that some parts of the video may be dense and tedious, but I'm telling them that, you have to watch that, you have to get through it, and you'll gain a lot.
Yeah, sometimes some things take time to digest, I think.
Yeah. So,
yeah. So thanks so much for joining, sir. Uh,
Oh, it's my pleasure. I think.
so I was just saying that even when Bhaskaran sir joined, said that some of the students had been requesting to meet both of you. Uh, so yeah, those who are here, they can please feel free. I think I've been saying this a lot in this meeting today. But please feel free to share whatever thoughts you have or whatever experience you had with the current course or the previous course.
Yeah, and if you're saying something, please switch on your camera so we can see you. Okay.
So I think so one of the students, one of the persons who is taking the course, Mr. Kamlakar, he is also, I think, very active on the discussion forum. Bhaskaran sir would relate to that. He had been requesting
Yeah,
to
I saw
meet.
a message from Bhaskaran about past exercises. I think.
Yes, sir. So I guess he has not joined the meeting yet, but uh,
Hmm.
maybe in a while he might.
Yeah, sure, sure. So I would, yeah, it would be nice if one can hear from the participants. Any suggestions? Any comments? Hello.
Hello.
hello, yeah, you're audible. Yeah, please go ahead.
Okay. So, first of all, I would like to appreciate the way in which this course is conducted. And I would like to thank Professor Deepak Shimani, Bhaskaran sir, and uh, big thank to Richwich sir for conducting this problem solving session. Without that, it will not be actually possible for us to solve the assignment. And I would like to say here that I am from mechanical background, and it is actually very difficult for us to digest this new topics related to AI. Previously, actually, I did a course on search methodologies, uh, to which I tried to give the maximum justice, and I actually passed the exam with like 60%. That way I got, and that inspired me to join the another course of Deepak sir, and I joined this knowledge representation course. But overall, my experience with the course is very good, and I will say that the level of the course is actually very nice, and the way it is conducted, that is also really good. But might be it is difficult for us to digest at initial level, but as we go on listening to videos repeated and repeated, then the concept gets clear. And most important is problem solving session that gives us proper input regarding the actually how to solve the problems. So overall, I need to thank. I would like to thank all the coordinators of this course. Thank you all.
Yes, thank you, thank you. And I must also add that without Bhaskaran and Ritviz, it would have been very difficult to to convey some of the ideas to the students, because everybody is short of time, and a little bit of help is always welcome, I think.
Yeah. Thank you, sir, and thank you, Darsh, for sharing your thoughts. Uh, Mohan, you had switched on your camera. Did you want to share something?
You're on mute, I think.
Thank you, Bhaskaran sir and Kamani sir. Things are, I mean, the course material appears to be lightly loaded, but really it demands a lot of deep understanding to answer the questions. There is a fine line difference between right and wrong answer. That's where the real problem is,
Hmm.
particularly in the logical conclusion of um, graphical objects, what you presented in the questions. Yeah, there is every possibility that you may choose a wrong answer. And that
Yes,
is what.
I realize that, and I think we have to be more careful while making the questions, so that there is no ambiguity of any kind, I think. Yeah.
Yeah, I think the subject itself is a little bit of an ambiguous topics are there. It's not clear cut, demarcated definitions of certain things. Are what I feel that sometimes I feel the answer is good for both the sides. So and that situations I just really take a chance and put up the question.
I think there were some doubts when we talked about logic and language. Bhaskar had also pointed out uh, something. And yes, there are certain topics which we go into depth, which perhaps we could have done less, I think. But I feel that it's if the uh, learner can get as much as possible, it's better for the learner, I think.
Yeah, it's fine. It's structured very well and it is progressed in the right order. And it's only basically we need to practice a lot to really get full understanding of the subject. It is mostly on us now. And
The other thing is that because of the fact that we have to do this objective type evaluation, multiple choice questions, it's a little bit harder. If we had the old style exams which were graded manually, then little bit of here and there could happen, partial marking could happen. But here that unfortunately is not the case. Though we do have partial marking for some questions where there are more than one correct answer, but that's a very strictly defined partial marking scheme, I think. That you should not choose a wrong answer, but you may choose less number of correct answers.
yeah, that's MCQ is really a challenging thing. if you choose one of the
like
wrong
Professor
answers,
mentioned, our medium of like Professor mentioned, our medium of evaluation, the exam interface, assignment interface is so limited because as a TA or as a professor, the team does not get to see your rough work because your level of understanding and your level of effort and intelligence really is visible when we look at the rough work. So when we
yes,
do a pen and paper correction, for example, with an IIT Madras, we get to see the rough work and we can evaluate the level of understanding and accordingly we can give out marks. So that component is entirely gone in the online interface that we have currently, right?
correct.
So it becomes difficult to set up MCQs and then evaluate. So I don't know. I mean, that's how the online system is currently. I don't know how to overcome that problem.
I think given the constraints,
So
we
that
should
also adds to
given the constraints, we should really take the full use
yeah,
of it. And I think online system is in a way
yeah,
good to get engage in more students, but there's a limitation. But that's the way it is, and
yeah,
you got to go by that.
yeah,
Thank you, sir, once again for the course material and the way the course were taken up
yeah.
Thank
and
you.
significant clarifications. Thank you very much.
Bhaskar, this question has been there for some reason, or?
So I just
I think
started with
Ritus
the
has put up this question here.
yes, sir. So I just started with the session.
Oh, okay, okay. So why don't you continue and maybe we'll step in between if necessary.
Sure, sir. Unless someone else also wants to share their thoughts. If not, I'll move on to the second question today. Okay, I guess not. So I'll move on. If anyone wants to speak up at any point, please feel free to do so. Okay, so here's the second question. Uh, so we are given two things, two statements. The first one is the plate was empty and the kid had jam all over his face. And then another statement is the kid must have eaten the jam. So this is an example of what kind of reasoning. So I'll once again let the attendees, the students go through the options while I'll create a poll for this question. Or you can also feel free to share your thoughts and unmute yourself and share your thoughts on the answer.
We didn't create the poll, is it?
I
Oh,
just created it,
okay.
so it should be accessible now. So we have one vote till now. What about the others? Okay, so Raghupati in the chat says that B is the correct option. And we have one vote for option B. Okay, so Argadev also agrees with it. And we have another vote for option A. So let's discuss the solution. So if you see, the statement is the plate was empty and the kid had jam all over his face, but we are not told explicitly that the kid ate the jam. So we are trying to hypothesize that the kid must have eaten the jam, right? And that is a kind of an example of abductive reasoning. So the correct option would be abduction in this case. So those of you said we.
This is the real good example for the confusion line. So why don't I really look it from detection point of view? Because there is a reason to believe that the kid having jam all over the face could have a possibility of eating that one also. Why am I going wrong there?
So if you were to go with deduction, how would you frame it in, let's say, in terms of some logic?
Kid, the plate
The
is
fundamental question is what is detection? 1 minute. The fundamental question is what is detection? When do we say that no, we are following detective principles? It's a detection.
making valid
Start from
arguments
there.
using deduction, no? Making a valid argument.
What is a valid argument? But
The
what
jam
is a
was in
valid
the
argument?
plate. Jam was in the plate, and the plate is empty. And what we could see that the
No, I'm driving you towards inference rules. So, okay, not this particular specific question, but what is detection?
detection
And when will
is
you say that I have followed the process of detection?
when I really
That
see
is
some
when you say, for
evidence.
example, at a simple level, if you have followed modus ponens or modus tollens, then
corroborating
we say it is
certain
detection.
corroborating certain incidents to the end result. That's a detection.
Yeah, it's a very rough statement. Now, having gone through KRR course, so when will you say it is a detection process?
So let me
We'll stick to the course and it will get.
let me step in again. Yes, I think the process of making
Yes.
inferences is a very wide ranging process. But if you look at deduction, then deduction is tied up to entailment, and entailment says that it is necessarily true. The knowledge base is given to you, and some query sentence is given to you, and we say that the query is entailed if whenever the knowledge base is true, the query is true. That is entailment. And deduction is basically just a syntactic or formal way of arriving at that. If you have a sound and a complete logic system, then whatever you deduce will be entailed, and whatever is entailed will be deduced, and so on. So, if you look at these two statements, three statements given to you, the two given statements are the plate was empty, the kid had jam all over the place. Is it necessarily true that he must have eaten the jam? That is a question. If that is the case, then it is deduction. If it is not the case, then it is some other form of influence.
That is a question, Professor. Now the kid has jam all over the place. Now whether the kid has eaten or not, it's left to the person relating the incidents here. But you said that it got to be must true in a detection. So there is an element of doubt that it is not necessarily true. So that is a point where
Yeah. So
detection has become an abduction. So there is no certainty that it has happened. That's the reason detection is failing. Am I correct?
yeah, I think you're getting it. So deduction is something, as Professor said, when you are absolutely certain about your uh,
Right.
conclusion and reasoning.
The entailment should be established. Then only the detection is right. Otherwise, it's an abduction. Yeah, I got the point now.
Not necessarily abduction, it could be another form of reasoning as well. In this case, it is abduction.
Yeah, but you're given three choices, and that one, the close running candidates are detection and abduction, is it? Induction definitely not there because we could not generalize that one.
Yeah. So I guess we do agree that abduction is the correct answer in this case.
Yeah, I agree with that one. No, I'm just trying to point out the point of confusion here. That's what it is.
Okay.
So, as I was telling earlier, that this minor difference is the one we are trying. We are really unfortunately losing the marks. So,
See, there is a Kamalakar induced post that relates to this one, the abduction, induction, and reduction from that corresponding week. So there's a lot that was written in that post. So those things at this point, having gone through the entire course, at this point, much of that should be clear if you read the post. If you have a doubt, you can repost it. I can
Yes, sir.
clarify.
I'll do that.
Okay, it is not difficult, and the examples given in the assignment are so nice. No, if a group of people sit and discuss and debate about those examples, you will very quickly understand and get an aha moment. You'll say, okay, now I understood what is induction, deduction, and abduction.
Yeah, I got that aha moment now when professor was telling about the entailment, and it got to be must true. These two keywords is the real one which really differentiates the case from abduction to deduction. So that is a final. That is the key things I missed to read it. That's always a problem with me.
I mean, that's okay. It's not.
Yeah.
Yeah.
Okay. Thank you, sir.
Yeah. Thanks for the discussion, Mohan and Bhaskaran sir and Deepak sir. So let's move on to the next question now, which is also a question along similar lines. So here we are given Tom is a white cat, Purr is a white cat, and Kitty is a white cat. And the other statement is all cats are white. So what kind of reasoning is this an example of? I'm not creating a poll for this one. Uh,
I, I would rather go with induction.
okay. So Mohan says he'll go with induction. Also in the chat, Orgodeep says option C is correct. What do others think? Okay, I guess everyone agrees that there are no conflicting opinions about the solution over here. This is an example of where we are trying to generalize, or we are saying all cats are white. So this is an example of inductive reasoning. So induction is the correct option in this case. Any doubts? Should we move on to the next question?
Yes, sir.
All right. Okay. Another question along similar lines. So all kids have a toy, and Annie is a kid. Annie has a toy. Now, what kind of reasoning is this?
Yeah, deduction.
Okay. So I hope now the distinction between deduction and abduction might be a bit more clear.
Yes, yes.
Okay.
No, okay. Can you say why it must be deduction? Now, why Annie has a toy, and how are you able to conclude with certainty that Annie has a toy?
See, all kids have a toy. So the qualifier is a kids. And the second sentence, Ani is also a kid. That's a matching one. So
So
Ani has a toy. That's
Mohan,
Basically, we are applying modus ponens over here. So applying
modest
modus
one.
ponens, you can come to the conclusion that Ani has a toy. So it's a deduction.
Okay. Okay. In the case of jam, how will you model the case of jam? Instead of plate, you consider it's a jar of jam. Okay, jam bottle. Jam bottle is empty, and so and so's face is covered with jam, and therefore I'm saying he ate all the jam. He ate the jam, right? He emptied the jar.
Yeah, there is not a definitive conclusion we can make it because there is no such thing, no such statement is making us to infer that the kid has eaten the jam. That's why it is abduction, not a deduction.
Can you state that problem in terms of logic statements, propositional logic? Can you model that example in propositional logic? Give a symbol for each statement and say it is true or false, and then put it in the form of propositional sentences. Can you do that? Rithwis, if you go back throw
Yes.
that slide on the screen. Do you have the ability to scribble on the slide?
No, sir, but I can use the Jamboard.
Okay. Ah, okay. So instead of plate was empty, you say the jar is empty or something like that, or maybe plate is empty. Fine. And can you copy paste that as an image here?
That would be a bit difficult, sir, but I'll just
See, the
share it.
general idea,
Yes, sir, please go ahead.
it's okay. See, the general idea is most uh, can be modeled in either propositional logic or first order logic. Okay. And if we are able to model it properly, correctly, and then if we are able to apply the inference rules, then it is deduction. I'm talking from a student's perspective, writing the exam, student's perspective, scoring marks. Okay. If I'm able to model it, but none of the inference rules, I'm able to apply inference rules, but I'm not able to deduce what the question says. I'm not able to clearly say, clearly conclude. That is where you have to ask, okay, is this an abduction? Is this an induction? And so on. So plate is empty, so you call it P. Then kid has jam all over his face, that is Q. Then kid ate jam is R. So if we include also, it is not included in the problem. If we say that R implies P, if somebody eats all the jam, then plate obviously becomes empty. And R also implies Q. He's a kid, so when he's eating, there'll be a lot of jam on his face. So these two were not given in that problem, those two implications. So we just had three statements, and we did not have the connections established. We have to fill it in, and then can you conclude by saying that, okay, he has the Q is true. So from Q is true, can you conclude that he ate it, that R is true? That's what professor covers in his lecture. And he says, if you do that, that is abduction, and then doctors often do that. You go to a doctor, he'll say, okay, you have high temperature. Okay, you're not able to taste, smell is gone, so you have COVID. There can be another illness which will have the same symptoms. So doctors do this abductive kind of reasoning. Abductive reasoning. He covers it very clearly in the lecture. So if we are able to model things, okay, as logic sentences, and then if we are able to apply the rules of inference to derive a conclusion, then that's deduction. But if you are going from the conclusion to the antecedent, then that is abductive reasoning. Inductive is, of course, based on observation. Sun always rises in the east. If it rains, the grass gets wet. And those are things that we have observed time and again. And the heavier the weight, the harder it is to lift and things like that. So those are observational science. And in mathematics and physics, chemistry, our basic axioms, basic stuff starts from induction. So it's based on induction, based on observation. Sun always rises in the east. This is based on my experience. Okay, I will start with that statement that came inductively, and then I'll keep that as an axiom, and then build other statements in the knowledge base, and then do reasoning according to inference rules. So, in fact, if you understand those principles, this ambiguity will never arise. The questions are very nicely done. Go back and revisit it. Okay.
Okay. Thank you, sir, for the explanation. Okay. So we discussed 4 questions. I hope there's no doubt.
This question is the question, the kind of reasoning we started the course with. The syllogism: all men are mortal. Ani is a man, therefore Ani is mortal. It's same structure, I think.
Right, sir. All right. So we'll move on to the next question then. So this question tells us that the logic machine is a set of rules of inference operating on a given set of sentences. And we can say that the logic machine is sound and complete. So we're talking about soundness and completeness if which of the following options is true. So I'll create a poll for this question and then students can go through the options in the meanwhile. Okay, so Raghupati says that uh, it can derive both false and true sentences, but Raghupati maybe uh, try to recall the definition of soundness. If a logic machine is sound, then can it derive both false and true sentences? Uh, what is your understanding of soundness?
So only true,
Yeah, you are saying something?
only true sentences.
Yeah, so that's right, right? If a logic system is sound, then it should not derive any false sentences, right? So now, would you like to rephrase your solutions? Also think about completeness.
A and C.
But soundness will have both true and false statements, a mixed bag of both.
Are you sure?
So if it is complete only, then all should be the true statements. Sound and complete it will have both few of the true statements and few of the false statements also.
Here the
So
logic machine is sound and complete, right?
yeah, sound and complete. Sound is there. If it is a complete, we can choose an answer. But it is a mix of sound and complete means there is room for few of the false sentences also.
No, how is there room for false sentences if the logic machine is sound and complete, right?
See, this is a typical recall type question, slightly added. Okay, we have added a little bit more, two of the questions together. This is a direct recall question about soundness and completeness. The definitions are uh, very nicely covered in the lecture. Uh, Sound means a system can produce only two true sentences. Complete means a system will produce all the true sentences.
Yes. But now sound and complete means
See,
can we have some
see,
few of the false statements?
I'll put it this way. If Jack speaks, he speaks only true things. He tells only true things. Okay, instead of that, I'll say Okay. If Jack solves a problem, the answer is correct. Okay. When Jack solves it, it is always correct. Does that mean Jack solves all the problem correctly? See, the
No.
statement is this.
If Jack solves a problem, it is always
If Jack
correct.
solves it, he will get the answer. If he solves a problem, he will always get the correct answer. But does
Yeah.
it mean he is solving all the questions?
No.
So you are attending KRR exam. If I attend the question, it will be correct. Okay, so that is soundness. So if Jack attends the question, he will get the answer correctly. Definitely, I know. That means we will say Jack is sound.
Jack is sound or complete?
Jack is sound
Why?
because he may
Because
attend only two questions. Because he may attend only two questions, and those two questions he will get it correctly, but he will never touch 98 questions.
that's right. So he is not
You see
attempting all the
how
questions.
these. So the statement is one-sided. It says whatever he attends, he will get the correct answer.
Mhm.
But
So
that
now,
doesn't say that he will attend all the questions. I didn't say that. Right? I said whenever Jack attends a question, he will get the answer correctly. So in this case, sound doesn't mean that Jack will score 100%.
but complete,
We can never infer that. We can never infer that.
but
Okay.
complete.
Complete means okay. The example that I gave for sound is not
Yeah,
extendable to
that is
complete now.
doesn't fit in there.
Yeah, it doesn't fit there. Okay. So let us not put a limit on the number of questions. Uh, let us say there are unlimited number of questions because we have to accommodate completeness here. Unlimited number of questions. And now we have Jack and say Bob. And so Jack and Bob. Jack, he will pick a question and he will answer and he'll correctly answer it. We'll say Jack's approach is sound. Then we'll say Bob, he will catch all the correct statements. So we have unlimited number of statements, some of which are true, some of which are false. So Jack is able to, whenever Jack solves something, he will only solve the correct questions and he'll get the answer correctly. So Bob, on the other hand, I'm saying he will catch all the correct questions. All the correct true statements he will catch.
So that is
In the
complete.
process, he will not, everything, he will catch everything. Okay, so I'll switch the example. This is a very ugly example. Okay, so let me, I'm recalling an example from one of the earlier runs. I have apples and oranges in a basket. I've switched the example. I'm sorry, guys. I'm just switch the example now for soundness and correctness. I'm mapping back to one of the early runs example. So we have a basket, we have 10 apples and we have 10 oranges. I'm saying Jack eats only apples. So does it mean he eats all the apples?
No.
I'm saying Jack eats only apples.
Yeah, but he's not necessarily he eats all the apples.
Yeah, he will just eat one apple and that's all. If he eats, he'll eat an apple, but he'll never eat an orange.
Oh.
When I say Jack eats only apples, I can conclude clearly that he may or may not eat the whole set. So it is ambiguous. I cannot say whether he has eaten all the apples or not. But I can clearly see he has not touched an orange. He has not eaten even a single orange. That much I can say. So the soundness is that. If I say Bob eats all the apples,
It's complete.
He has eaten all the apples. But can you guarantee that he did not touch an orange?
No.
That's it. That's soundness and that's completeness. So the
Yeah.
mathematical definition of soundness
So
says,
what you are telling that there is a potential that he ate all the apples and could be some oranges also. That's why it
when
is
you say
sound.
complete, that is, he will complete the work and he may do more work also. I don't know. But he will do everything, complete it, everything, fully. That is completeness. So apple, if it stands for true statements and oranges stand for false statements, then you can directly map it to a proof procedure here. And this example is from one of the earlier runs.
Yeah, but in the question here now, the option should have few correct, few true, and few false sentences. Is it? That's the right answer.
Uh, no, the few false will not be here because it is also sound, right? It is sound and complete, both. It's not just complete. So sound doesn't allow to derive any false statement. So if you, like a Venn diagram, if you mix those two, sound and complete, then you cannot derive any false statement out of this.
Is that the way we should read it? Because when the complete is there, sound is non-existent.
No. Sound and this is sound and complete. It can be just sound. It just can be just complete. It can be just like forward chaining and backward chaining. It's just sound. It's not complete. But resolution
Yeah.
definition is sound and complete. So it's
See, with the apple and orange example, if I say Mike comes and Mike eats only apple and he eats all the apple, that's sound and complete. In terms of the example, apple orange example, take apple as true sentences, orange as false sentences. You can map it to this problem, but we will talk in terms of apples and oranges. So I'm saying Jack eats only apples. That's one proof procedure. Jack is a proof procedure. He eats only apples. And there is Bob. He eats all the apples. That is another proof procedure. Then I have Mike, who eats only apples and he eats all the apples. So in terms of practical example, that scenario, the apple orange scenario, now maps to exactly this question.
Yeah. So thanks for the fair explanation, Bhaskaran sir, and also for your inputs, Orgudi. So Mohan, I guess it should be pretty clear now, right?
Yes.
Wait. Yeah, okay, you went to the answer file.
Okay. Yeah, so the correct options in this case are it can derive only true sentences and all true sentences, and it cannot derive any false sentences. Um, okay. By the way, Bhaskaran sir and Deepak sir, I hope I'm not taking up too much of your time. Uh,
Actually, I need to go and do some shopping.
okay.
And so if anyone wants to ask anything or say anything uh, before I go, I think.
No, sir. I think
Okay. Thank you all. Thank you, Ritesh, for doing all this. And thank you,
appreciate your.
Bhaskar, for
Thank
chipping
you.
in.
Thank you, sir.
Thank you, Professor.
Thank
Thank
you,
you.
sir.
Okay. Bye.
Thank you
Bye.
for
Thank
taking
you,
time.
sir. It's an honor after seeing your lectures for 1 year straight after doing SMPS and also doing KRR. It's really an honor to see you.
Thank you, Argadeep.
Yes, sir. Thank you very much.
Sir, what is your next offering, sir? First,
Sorry?
next course, what is that you are offering, sir?
See, on NPTEL, we have 3 courses.
Okay, sir.
These, this KRR, then there is search methods, and there's a course on constraint satisfaction,
Yes, sir.
which got over this semester, I think.
Okay, sir.
Okay, thank you then, I think. Thank you.
Thank you, sir.
Thank you for attending, sir. Thank you for taking out time.
Thank you, Professor.
Uh, Bhaskaran sir, is it okay for you to stay back a while, or do you also have to leave?
Yeah, I'll stay for some time and then I'll
Sure,
drop
sir.
off. And if you want me back, just WhatsApp me. I'll join.
Sure, sir.
So I'll stay for a few more questions. And then drop.
Sure, sir. All right. So let's move on to the sixth question then. Okay. So here we are given two statements and a conclusion. The first statement is, if the student made an effort, then he will succeed. And the second statement is, the student made an effort. Conclusion is, therefore the student will succeed. So is this conclusion valid or invalid? So I'm not creating a poll for this question. It's pretty straightforward. Um, Again, try to think of it in terms of the deduction example or the previous reasoning examples that we just discussed a while back.
Valid.
Valid, valid.
Yeah. So thanks, Olgodi, for your answer in the chat, and also Mohan and Raghupati. Um, so yeah, all of you are correct. It is a valid form of conclusion because this is a valid form of deduction that we did right here, right? So we can frame it in terms of modus ponens again. We can say that if students made an effort, then he will succeed, which can be framed like if student like effort implies succeed and the student made an effort, right? So the student will succeed. All right. Um, any doubts on this question, or should we move on to the next one? All right. That's great. If there are no doubts, let's move on to the seventh question then. So here we are given a knowledge base, which is made up of these uh, facts. The first one is P implies R, then we have not R and T, then we have T implies P, and then we have not P and Q together imply not T and Q. So given this knowledge base, which of the following among the options can be derived from the knowledge base? So I'll create a poll while the students can go through the options and think about which of them are correct or can be derived from the knowledge base. Okay, so I've created a poll. Um, Please feel free to share your answers there, or you can unmute yourself and speak up, or you can write your answers in the chat box as well. So one of the answers that people have voted for in the poll is all except option D are correct. And let's look at the solution. So from this particular fact that is given to us, we can get not R and T, right? Now using this T and this T implies P, we can get P. Then using P implies R and this, we can get R. Now since we have not R over here and P implies R over here, we can use not R and P implies R to get, what can we get? Any guesses?
P.
Will it be P or not P?
Not P by modest tolerance.
Yeah, that's right. So remember we had something like this, right? So using that we derive not P, and now since we have not P and Q, both of them, and this as well, we can derive not T as well. So if we revisit the options, the only one that we were not able to derive is not Q. So all except option D can be derived from the knowledge base.
So I just took all available letters,
Mm-hmm.
then that fits into the option all except D, because all the other letters are there in the relations.
No, here when I said all, I meant all options. All
Yeah,
options,
all
right?
options. Yeah, that's what I'm trying to tell. So
Yeah.
I didn't do this relationship diagram. I just went through the relationships and I started looking in what are all the letters and
What do you mean by letters? Do you mean P, R, T symbols?
PRT and all. Okay.
Okay.
So only the not Q is not there. Everything else is there.
No, I would say that is not the uh, right approach. I would say so. You're asked to say see what are the which of the following can be derived from the knowledge base, right? So it's better to apply all the rules of inference that you know and
Okay.
see which among these options you are not being able to derive. And if you're not being able to derive something, then it's probably it cannot be derived, right?
Yeah. I just solved some few problems and saw that that's generally the way what it is falling in place. Some sort of an induction I derived that.
See, I will intervene here.
Yes, sir.
Okay.
Three
The,
problems
the,
I tried and it's matched, so
no,
I concluded that way.
no, cannot do that because the course material is much more deep and much more is used widely in many places. Okay.
Okay.
The line of reasoning and thought process that is covered in this course. That's what I mean. See,
So it so happened that it is matched. That's what I'm trying.
yeah, it's so horrible. Please don't do that because if we take a court argument that happens in a say a criminal case, and if we formulate it in terms of propositional logic, and the judge should be able to conclude without any doubt that the accused has actually done something wrong or that he has not done something wrong. It's a life or death situation.
Okay.
The method that you used can never be used in a court of law. Okay, practically speaking, our court of law is operating at a different level. Or to change the example, if a detection is happening in a system, in a software that is managing a nuclear reactor,
Hmm.
and if we use what you described, then there will be a catastrophe. Okay, so we cannot do that. You have to show a proof, like Professor mentioned. You have to show an entailment.
Entailment.
You have to use a proof procedure that is sound and complete. And when you do the derivation, you should have done it without mistakes. Of course, when you do it manually, you should make sure in an exam that you have done it without mistake. But if these things are applied, coded, and applied as an algorithm by a computer, say nowadays we have AI systems. Now, if an AI system does an inference and then it decides to take an action, it better do a sound and complete inference and then take an action.
Got it.
Okay.
Thank you, sir.
Not looking at symbols and saying, okay, then I'll take this action. Oh my God, we are doomed. Okay.
Okay.
Uh, yeah. Thank you for the discussion, Bhaskaran sir and Mohan. Uh, so I hope any remaining doubts on this question are now solved. Should we move on to the next question then?
Yes, sir.
Okay. Okay. So here we are told that let sister and brother be function symbols, let talented be a relation symbol, and let Rahman be a constant symbol of LPFC. Now, which of these four options that are given to you, A, B, C, and D, which of the following are sentences of FOL? Okay, so we had discussed a similar question in the live session where we covered this particular topic. So try to think about the definition of a sentence in FOL and then look at the options. I'll also create a poll for this question in the meantime. Okay, so I've created the poll and we already have one vote. What about the others? What do you think? Okay, so the one vote we have is for options A and B. So why do you think would option C and D be incorrect in this case? Why won't there be sentences of first order logic?
Sir, in C, X is a free variable. Free variables cannot be in a sentence. And in D, there is a function symbol, but function symbols cannot be in a sentence as well in FOL.
Okay, thanks, Argodeep. Um, would anyone else also like to add on to it? Okay, so yeah, so A and B are in fact the correct options in this case, and the reason C and D are incorrect is that, as Argodeep said, in option C, X is a free variable which cannot be there in a sentence in FOL, and in option D, well, brother and sister are function symbols, and they are not exactly in the way that terms are present or structured in a sentence in FOL, right? So if we just go back to the definition of first order sentences in first order logic, you'll realize that option D is not actually a sentence in first order logic.
So why C? What is wrong in C?
So you have this x over here, right?
Yeah.
This x is a free variable. So what are the values that x can take?
Uh, let's just run the B function.
And what is a sentence in FOL that you recall from the lectures?
No, I'm not able to get the question here. Which of the following are okay? So it's
So
just
try to remember the definition of a sentence in first order logic. Go back to the lectures if you have them open side by side.
yeah, I think somewhere.
See, the hint here is in computer science and especially in mathematical logic, we have formula and we have sentences. Sentences are formulas, but the other way around is not true. Okay, formula is a expression that is well formed without any syntax error. And sentence is a formula whose truth value can be known, or it has a truth value. We may not know the truth value, but it definitely has a truth value. You get the point.
Yeah,
The
I'm listening
formula
to
is an expression.
just going through the notes.
And these are all straightforward recall questions, okay, on basic definitions.
Okay, sir. Let's first start with logic. Okay, and it's another one. I will take it up and I will read it out separately, sir. I don't want to delay it.
Okay. You can also revisit the previous live session where we discussed this particular kind of questions, and I hope that also might help.
Yeah, yeah, I'll do that. I'll do that.
Okay. Thanks once again, Bhaskaran sir, for your explanation, and Mohan for your question. Let's move on to the next question then, which is about CNF. So here we have to select among the 5 options that are given to us, the formulas that are in CNF form. So once again, try to remember what is CNF form and answer the questions based on that. I'll once again create a poll for this question. Sure, sir. We'll ping you detail. Thanks for taking it on, sir. And thanks for taking your time for joining the live session. Okay, so I've created the poll for this question. Please feel free to share your answers over there. Okay, we have one vote for options B, C, and E. Um, so would anyone like to share their thoughts on why they think B, C, and D are the correct options? Or if someone thinks otherwise, they can share their thoughts on why they are not. So think about the expansion of CNF, right? So what is CNF? CNF is a conjunctive normal form, right? So we have a conjunctive or conjunction in there in the definition itself. So does that give a hint? Okay, so yeah, so those of you who did vote for options B, C, and D, they are correct. So B, C, and D are the correct options. So if you remember, a conjunctive normal form is basically, would anyone like to say what it is?
Sir, conjunction of disjunction of literals.
Yeah, that's right. And thanks, Argodeep. And so which of these options fit that definition?
Sir, B, C, and E here.
Yeah, that's right. So so basically, as Argodeep pointed out, it's a conjunction of clauses where each clause is a disjunction of literals, right? And each literal can be A or not A, right? Where A could be replaced by any other literal as well. So B, C, and D are the ones that fit that definition. Uh, A does not fit that definition because we have a not outside the bracket, which is not something that is uh, there as per the definition of CNF. So that does not belong to the CNF form per se. And then in option D, we have implications, which also do not fit into the definition of CNF. That being said, there are formulas that can be converted into the CNF form and that you can explore later on as per the options given. But for now, B, C, and D are the correct options. Okay. Any doubts on this question? Should we move on to the next one? All right then. Something along similar lines. Here we are asked about clause form. So which of these formulas are in clause form? Once again, remember the definition of clause form and have a look at the options. I'm not creating a poll for this one. You can feel free to share your thoughts on which of these options would be correct in this case. Okay, so Orgodeep says that options A and B are correct, um, and C is not correct. What do the others think? Does everyone agree? Okay, I guess everyone agrees. And so a giveaway over here is that option C has an implies in between, right? Um, and that is not exactly something that belongs to the clause form, right? So C is incorrect, and consequently D is also incorrect. And options A and B are belonging to the clause form, so they will be correct options in this case. Also, option C is not parenthesized correctly, if you notice. Okay, any doubts on this one? Should we move on to the next question then? All right. Now we are moving on to a question related to prologue or cuts specifically. So which of these following sentences are false? Okay, so you are given 4 options and you have to tell me, or you have to decide which of the following sentences are false. So what do you think? Remember what a green cut is and what a red cut is, and what does removal of one of these cuts can do to the output or the meaning of a program, a prologue program. Okay, so Orgodeep says options B and D, which is in fact correct. So a trick or a minor detail over here is that you're asked which of the following sentences are false, not which of the following sentences are true, right? So you have to be careful about that. So green cut, removal of a green cut from a program does not really influence the output, right? So here we have to select an option that is the opposite of that, which is option B. Removing a green cut changes the output of the program, which is false, and hence we have to select that. Similarly, for a red cut, a removal of the red cut does change the output of the program, so we have to select the opposite of that, which is option D. Removing a red cut does not change the output of the program. So options B and D are to be chosen as false, or as the answer that you would have answered had this question been asked in the form of a multiple select question. Okay, any doubts on this one? All right then, thanks for the thumbs up, Arkodeep. Let's move on to the next question then, which is from the territory of rule-based systems. So here you are given a rule on this uh, figure over here, and you have to decide how many classes are referred to in the rule given here. Okay. So once again, remember the structure of a rule from the lectures, and remember which of them is a class, which of them is a rule name, which of them is an attribute, and which of them is a value. And here you have to decide which of these are classes from the structure of the rule, and how many classes are referred to in this particular rule that is given over here. The rule name is P vaccine 1A, and you have to decide how many classes are referred to in here. Okay, so once again, we have an answer in the chat box, which is 3. Orkodeep says 3 is the number of classes. Do the others also agree, or do you think otherwise? Okay, so which of these are the three classes that you think are being referred to here? In case everyone agrees.
Sir, first dose today and eligible.
Yeah, that's absolutely perfect. So those are in fact the three classes that are being referred to. The first one is eligible, then it's today, and then it's first dose. So three is the correct option in this case. Okay. Thanks, Mohan, for your answer as well. 3 is the correct option in this case. All right, let's move on to the next question then. So this one asks us, which of the following is the correct first order logic representation of the statement all kids are innocent? So remember, the key word here is all kids are innocent. All kids. So which option do you think would be the correct fit for the FOL representation? By the way, I hope my audio is clear. I think my mic got disconnected for a while. All right. Okay. So if you recall from the discussion that we previously had, since we have all kids over here, we will have a universal quantifier, and we also need to have an implication over here, because if we had an and, that would mean that every x is a kid and every x is innocent, right? Which is not what is said in the statement over here. We have said all kids are innocent, so we need to have an implication. So for all x, if x is a kid, that implies that x is innocent. So as pointed out by Arkadeep and Mohan in the chat box, and I guess Raghupati also agrees, um, B is the correct option in this case. Okay. Should we move on to the next question then? Okay. Something along similar lines. Here we are told the statement is some people are funny, and we have to select the correct FOL representation. So here the keyword is some people are funny. Some people. Okay. So try to think a bit more about it. Does this need to have an implication over here? It does not, right? So we are told that some people are funny, which means that there exist some people which are people and which are funny, right? So option C fits the bill.
Can we compare both the questions 13 and 14? Why the implication is not selected?
Sure, think about it. So here option D says there exists people X implies funny X, which means that there exists some X such that if X is a person, that implies that he's funny. And what the statement tells us, some people are funny, right? Which is kind of a more fit of option C. There exists some X so that X is a person, X is a people, and X is funny. Again, this is also a recall based question. So if you revisit the lectures, there has been, if I remember correctly, examples of both such kinds of examples have been demonstrated in the lectures, right?
So this is where really we get into a bit of a confusion most of the time. Yeah, we'll
So
see that answer, right?
sure. So once again, as you were also pointing out earlier, the more the examples that you encounter, the more number of times you go through the lectures, it will become more and more apparent. All right. So we'll move on to the next question then. So here we are shown a figure which shows a domain that has many individuals, but only 5 of them, basically I, J, K, L, and M are shown in the figure over here. And furthermore, we are told that the subset relations in the figure hold in all interpretations of the domain. So what we have to do is we have to identify the statements that are true. So which of these 4 statements do you think are true? So remember this figure or this symbol over here, this is a representative of when something is subsumed, right? So Orgodeep says that options A and C are correct. So I'll give you a hint. What about option B? Can you say that all witty people are studious based on the figure that is given to you over here? Yeah, that's right. So yeah, both Orgodeep and Mohan, you both are uh, together correct. Options A, B, and C are the correct options in this case, right? Because witty is part of this vertical rectangle kind of structure which is representative of athletic, right? So witty is a subset of athletic people, right? So witty is subsumed by athletic, and similarly witty is also a subset of studious people. So option B is also correct. And option C says that some athletic people are not studious, which is what J and K over here stand for, right? J and K are examples of people that are athletic but that are not falling in the boundary of the studious people, so they are not studious. And hence all studious people, option D says all studious people are athletic, which is also incorrect because we have people like L and M, right, which are studious but not athletic. So option D is incorrect. So options A, B, and C are correct in this case. All right. Uh, should we move on to the next question then? Okay. So the next question asks is related to CDs. So we have to decide the CD representation of this particular statement that is given to us, which is Ahmed gave Rahul a toffee. Which of these options do you think would fit the question that is given over here? Does it involve the use of P trans, A trans, M trans, or does it imply the use of cache? So once again, if you recall from the lectures, P trans involves a physical transfer of something, right? M trans involves a memory based transfer, right? And A trans is something like giving or buying or taking something. So given that information, which of these options do you think would be correct? Okay, Mohan says A would be correct. Would anything else be correct? A trans would also be correct in this case, right? Because A trans involves something like giving something or buying something or taking something, right? Whereas we do not have any memory transfer involved over here, neither do we have any implied use of cache. So options A and B would be the correct options in this case.
Sir, here in B, there is no clarity that there is a buying and giving something like that, no?
There is clarity, Mohan. So you see this particular word gave over here gives away that a giving of something is involved, right?
That is not sort of a sale transaction or something like that, no? That's why I didn't
Yeah,
take it. I had confusion, but there is no visibility of real purchase transaction.
yeah, there is no visibility of a transaction. Hence, we are saying that option D is incorrect.
Yeah, option D is incorrect. That's clear. Okay, so all right. So air trans is also applicable.
Yeah. In fact, if you go back to the lecture slides, it's specifically mentioned below, just below A trans, give, buy, and take are examples of A trans.
Okay.
Okay. So, okay. Let's move on to the next question then, which is related to inheritance graphs. So, given this inheritance graph over here, A to B, B to C, C to D, and there's another edge from B to D, which of the following are true? So, does B preempt, node B preempt edge CD, and is BD a redundant edge? These are the two things that you have to decide upon, and accordingly you have to select which of these options are true. So what do you think? Remember the definitions of preemption and redundant edges? So um, you are correct about option C over here, both Orkodeep and Mohan. C, BD is a redundant edge, but does B really preempt edge CD? So remember in the definition of preemption, yeah, so we had something like, okay, I'm not drawing the whole thing. This is, let's say, some graph. This was an edge in the graph, okay? And then we had some node over here that was either like this, or you had something like this, right? So remember the difference between a positive and negative edges. Now do you think node B preempts edge CD? Yeah, that's right. It does not. So the correct options here would be B and C. And once again, I'll point you to the notes on the specific notes on this particular topic that was prepared by Bhaskaran sir and uploaded in the uh, lecture slides material in the drive folder. All right. So Raghupati, you can maybe mute yourself if you do not have a question, or even the other attendees. If you have a question, please feel free to unmute yourself. But otherwise, it would be great if you could uh, introduce the noise issues. All right. So let's move on to the next question then. Oops, there is an issue over here. Okay, sorry about that. Just give me a moment. I'll go back to the question. All right. So this is the question. You have to identify which of the following are definitely universally true statements among these 5 options given to you. Okay. So which of these do you think would be definitely universally true statements? I am audible, right? Okay. So thanks, Mohan. Mohan says that E would be uh, definitely universally true statement. And what about any of the other ones? That's right. Algodeep and Raghupati are both right. E is one of the definitely universally true statements, and A is also one of the definitely universally true statements. All men are mortal is also definitely universally true, and all the other options B, C, and D are not definitely universally true. So the correct options in this case would be A and E. Okay, so sorry about that. All right, so that brings us to an end of the questions that I had for today. Uh, so before concluding, I just say all the very best to all of you, uh, not just for the exam that you have in a couple of days, but for whatever you might be interested in pursuing later on after this course. And hope you all succeed well. And special thanks to Professor Deepak Kimani and Bhaskaran sir as well for taking out their valuable time and joining the session today and interacting with some of you. Um, yeah, so is there anything specific that any of you would like to discuss?
So, what is your guidance for having a confusion-free knowledge acquisition? How do
Uh,
you really go for it?
you mean confusion, how to avoid confusions during while giving
Yes.
questions?
Yeah.
What I would suggest is definitely meticulously go through the lectures, right? And try and prepare your own notes if you haven't already. That will help a lot.
Okay. Do
Yeah,
you have a cheat sheets for each week, one pager, anything like that?
I don't have that, but I guess the notes that are provided to you by Bhaskaran sir for some of the weeks, uh, like the inheritance network week or the conversion to clause form, those kind of weeks, or these can
How do you
be.
locate that one, sir? Bhaskaran sir's additional notes.
So if you just go to Swayam portal, no,
So I
uh,
am portal and
just give me a moment. I'll see if I can
Can
locate
you
it.
give a link of that one?
Yeah, I'm showing it to you right now. So let's say week 4 over here, right?
Yeah.
Just go to week 4 and you see lecture materials over here.
Yes.
Just click on that. It will lead you to a page like this, and here you have a link. Click here to download lecture materials. This will lead you to
Yeah.
a drive folder that has the lecture slides and some of the notes in some weeks.
That's not the same as the Professor Kamani's material.
It has the lecture slides that Professor Kimani uses in the videos, as well as some of the weeks have additional notes that are prepared by Bhaskaran sir.
Oh, okay.
Yeah. For example, I'll show you an example. If we go to week 5,
Okay.
okay. So here you see one example of week 5 resolution slides. Okay, this one.
Uh,
And then there are two notes that are prepared by Bhaskaran sir. So you can have a look at that if you haven't already. Okay.
all right. This is not the regular page what we really see it for Professor Kamani's lecture. It's a different portal.
No, this is the same portal where you have all the videos and the assignments.
Okay, okay. Okay.
Yeah.
Sir, do you still have those Jamboard files of previous weeks where the big deductions were done? Those printed ones. You still have those of week
Uh,
4, 5?
Unfortunately, I don't have those Orkut because I used to reuse the same Jamboard every week, so it got deleted. Uh,
Okay, okay.
but I guess they are recorded, so if you want to revisit some
Yes, yes,
particular
yes. Okay, sir.
question, yeah, you can always revisit the YouTube links.
Yes, yes. Yes, I was going through the recordings and not those that you used to write, but there were some Jamboard files where it was already done, printed, like computer done, like the resolution refutation. I remember that taxpayer house one, and also some of the big deductions. Not those that you used to draw and used to explain us, but
Yeah,
already done ones.
yeah, even those I don't think I have in my Jamboard currently.
Okay, so it's not an issue. I will see the lecture second and I will screenshot those. It's not a problem. I just asked.
Yeah, sure.
Yeah.
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 All right then.
Thank you, sir. Thank you very much. And it is really a
Sir,
very good prepared material for us.
Thanks, Mo.
thank you, sir. When this course will be offered for the next time?
Um, so I think in the next semester, the SMPAs or search methods would be most likely offered, and in the following one, I guess
Okay.
this course will be offered once more.
Okay. Okay.
Yeah.
Thank you, sir. Thank you so much.
All right then. All the very
Yes,
best
sir.
to.
Thank you very much. I
Thank
am
you.
seeing you from June of the last year from SMPS, and it's a habit. It became a habit. Every Tuesday I used to come from college and uh, see the problem solving sessions. So yeah, uh, I will miss you obviously. These sessions. It's continuing from June, and it's already May of this year. So yes, it
So
has been it became a habit.
thanks a lot, Arkadeep. I'm glad
Yes.
that this sessions could be of any help to you,
Yes,
and
obviously these are of immense help.
and so we never know. We meet again in the next semester as well, if we happen to uh, take on a similar course. Uh, let's see. Uh,
I am looking forward to take the machine learning course by IIT Madras. I cannot recall the name of the professor, but there is a machine learning course from IIT Madras professor. It's a 12-week course as well. I'm looking forward to take that in the next semester actually.
okay, it might be Professor Ravindran.
Yes, yes. It's in the NPTEL artificial intelligence domain only.
Yeah. So that is not actually in my hands, which course I get allocated, but let's see.
Okay, sir. Okay.
Okay.
Good night, sir. Good night. Thank you very much.
All right. So all the very best, and thanks a lot for attending. Uh,
Okay.
okay. Let's close this session.
Right.
All right.